So my goal is to, what is this, week 7? To get through all of this in week 7, okay? So don't stress out. It seems like a lot, but I'm going to be skipping here and there to make sure we're good to go, okay? What I want you to see is, this is the big thing. Undoing is really going to be inverse. And if you look, here's inverse again, here's inverse again, here's inverse again. And we're going to be focusing on certain kinds of inverse. You're going to learn that the inverse of an exponential function is a log function, okay? And then transformations, you know how to do that. So let's turn the page, and let's see. So they're talking about undoing. So let me zoom in and see what's going on here. All right, we've got that basic introduction, blah, 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 but let's look here. So you're going to think of a number. Okay, some of you go, well, that's a fun game. I'm thinking of a number. If I add 10 and multiply it by 2, my answer is 16. What's my number? And you guess and you guess. Well, that's what solving for x is. If I'm thinking of a number, you take half that number, you subtract 3, and you divide it by 2, and then add twice that number, and you get 16 minus that number. Anybody guess my number? Or you would solve this crazy equation and you would find x. That's pretty much what it is. So they're introducing it that way. So let's see. When I add 4 to my number, so I don't know what my number is, so I call it x. I add 4 to it. And then multiply that sum by 10, I get negative 70. So what is the number? Well, you guys know what to do. You would multiply. 10x plus 40 equals negative 70. 10x equals negative 110, x equals negative 11. Now, I actually want to challenge you and show you that I would have actually solved this problem differently. I would have divided by 10. I think that would have been way quicker. I want you to think about that when we get through this problem. And then now, x equals negative 11. Okay. All right, so now it says she puts 3 into the machine and 7 comes out. So you put 3 in, 7 comes out. You put 4 in, 9 comes out. She puts in negative 3, negative 5 comes out. Make a table to organize your inputs and outputs. Okay, so I'll go like this. 3, 7, 4, 9, negative 3, negative 5. Okay. This is kind of one of those things where it's a puzzle. You either see it or you don't. But let's see. Explain in words what this machine is doing. This machine is taking this number, multiplying it by 2, and then adding 1. Let's see. 2 times 4 plus 1. Great. Now they want you to go backwards. If 7... Okay, so this was, I think of a number, I multiply it by 2, I add 1. So that was my equation, right? Now what they're saying is this time, what if you have this, you have the y, so you have the 7 and you've got to get back to 3. So it would be the first thing you would do. So it looks like, well, okay, the way to get backwards would be subtract 1 and then divide by 2, and that'll give you x. Well, let's see. If I take 7, subtract 1, that's 6, divide by 2, I get 3. So what I want you to see is this 2 that was here is now here. This plus 1 is now minus 1. Okay? Anita sets up her new backwards machine and enters the other options. What would you expect to come out out of the top if 9 is entered? So now they're saying, okay, this time put the 9 is in here. 9 minus 1 over 2. X equals 4. Okay, we don't need to do the negative 5. Record the inputs and outputs on a table. I think it's fine. Write equations for the original and the backwards machine. So we did that already. The original machine was y equals 2x plus 1. And her backwards machine is y minus 1 over 2 equals x. Okay? You're going to be learning that this will be the inverse that we were talking about on the first page. Okay, let's come here. All right, so whenever I see f of x, it's really just y. So if it might make it easier if you think about it this way. So I'm thinking of a number, I multiply it by 5, and I add 2, and then you get the number. So if the crank is turned backwards, what should be pulled in? Okay, so let's do this. 4, then you multiply it by 5, then you add 2, you get 22. So if you started with 22, so you're starting with 22, how the heck would I go backwards to get to 4? Well, think about it. What was the last thing you did? Was add 2. So if the last thing you did was add 2, if you're going backwards, the first thing you're going to do is add 2, but it's backwards, so you subtract 2. Then the next thing you did was multiply by 5 when you went this way. So backwards would be divide by 5. And that gives you x. Well, let's see. 22 minus 2 is 20, divided by 5 is 4. Good. So in the original machine, you multiplied by 5 and you added 2. In the new machine, you subtracted 2 and divided by 5. Do you see how I went this way, and now this way I go the other way? Okay. So they want you, okay, what must I go do to 17 to undo f of x and return a value of 3? Okay, well they're saying, okay, if you want to undo it, you're going to put 17 in there. 17 minus 2 over 5. 17 minus 2 is 15, divided by 5 is 3. Oh, all right, that's an undo machine. That means I could do the original machine. Let's see if I do the original machine. I multiply it by 5 and add 2. 15 plus 2, 17. Okay? If here's school and here's home, if I go right 5 blocks and down 3 blocks, and you're like, how do I go home? Well, what was the last thing you did? You went down. So what would be the first thing? Up 3. So if this was down 3. And you went right 5, what would be the next thing you would do? Left 5. You're going backwards. Okay? So they're telling you that this is called the inverse, and I guess it doesn't matter what color I use. What color did I use for here on the first page? Inverse? No, I used yellow, whatever. So whenever you see inverse, you're going to write it as f of x. So what that means is you're going to give me the original version, function, which is f of x equals 5x plus 2. And now what I'm going to do is instead of calling it y minus 2 over 5, I'm going to say f inverse of x equals x minus 2 over 5. So if I do this machine, I can get the same thing as this one. What does that mean? If I had x, f of x. So I'm going to use this machine for this one, okay? Just so you can see. If I put in 1, I get 7. If I put in 2, I get 12. If I put in 3, I get 17. Well, let's see. What if I have my new machine? I don't really know what the questions are asking, but I do know that this is helpful. Okay? What if I put in 7 to the, oh, let me do this, whatever. This is this machine, that goes there. If I have 7, 7 minus 2 is 5, divided by 5 is 1. Okay? What did I say? This one was 12. If I have 12, 12 minus 2 is 10, divided by 5 is 2. I'm doing awesome. And then I'm going to try 17. 17 minus 2 is 15, divided by 5 is 3. Look at this. This is 1, 7. This is 7, 1. They are inverses of each other. Okay? So, let's just pretty much, the idea is inverse. And the idea is that anytime we see inverse, we do f of negative 1 like that. Okay, now some of you go, why is it f of 1? Okay, well, if I show you f of x, it could be to the first power. It's imaginary. Like if we put x, we know that means x to the first. So the inverse of something to the first power is something to the negative 1. Why is that? Because when you multiply exponents, what does it mean? It means you really add them. And that gives you one thing. If I have x cubed times x to the negative 3, that's x to the 0, which is 1. Inverse. Okay? All right. So we've got a new machine. We've got a new function. So g of x, you're thinking of a number, you add 5, you then divide by 2, you then cube it, and then you multiply it by 6. So we had step 1, 2, 3, 4. So if I was going to undo my machine, okay, oh, and I guess that's the equation right there. Okay, what is the output when 3 is the input? So you would take 3, plug it in, and then you'd go 3 plus 5 over 2 cubed times 6. 3 plus 5 is 8, divided by 2 is 4. 4 cubed is 64. I don't know what 64 times 6 is. I could probably figure it out faster than I could just okay, 384. So when my input is 3, my output is 384. And some of you go, what? That's when you go f of 3 equals 384. Or you write it as the point 3 comma 384, where this is the input and this is the output. Now they're asking you to undo it. It means they want you to find the inverse. Okay, so if this was step 1, 2, 3, 4, now I'm here. How do I go back? Go backwards, divide. Okay, so I'm going to divide by 6. Instead of cube it, I'm going to cube root it. Instead of dividing by 2, I'll multiply by 2. And instead of adding 5, I'll subtract 5. Okay? So I take my number, I divide it by 6, I cube root it, I multiply that whole thing by 2, and I subtract 5. And that should be my inverse. Okay, let's see if I'm right. So, if this one, when it was f of x equals 384, technically f inverse of 384 should equal 3. So that means I should be able to put 384 in here, and I should get 3. So let's see. The cube root. All right, so let me go 384 divided by 6 is 64. The cube root of 64 means what? Times what? Times what is 64? That's 4. Times 2 is 8. Minus 5 is 3. Oh, that means that this is the inverse of that. Inverse. Switch. Okay? If I am over here, and I go right and then down, I have to go up and then left. Okay? Always do the opposite. That's the inverse. All right. I'm going to stop the video here and we'll finish this last page.